Hi everyone, we are moving on to learning target 6 in chapter 1, and we are partitioning a segment, which basically just means we're cutting it. Okay, what you need to know is that the order matters. So if I say 3 to 2, that's how you would read this, the 3 goes first. Let's talk about candy, okay? So this means that I get 3 pieces and you get 2, because clearly I'm getting more than you are. What also matters is that altogether I have 5 pieces. So again, 2 to 3, that means you would get 3 and I would get 2 and I would not be happy, but we would still have 5 total. So the order matters. So if point P is partitioning the segment, and so right here, that's in a ratio of 1 to 3 because we're going from A to B, 1 to 3. And if I said 3 to 1 from A to B, I would have gone 3 to P and then 1 to B. So that's just again showing you that it's a total of 4 parts, but the order matters. So same thing here, 1 to 2. For every 1 there is 2, so there's 3 total parts, and vice versa. So determine the ratio of the directed line segment BA, so notice the order of these letters, BA, when partitioned by point P. So if P is here, because it said BA, I'm going to start counting from B. So this is 1, 2, there, so that's 2, and then I would count 1, 2, 3 to A, so that's 3. So my ratio would be 2 to 3. Same thing here, I start at B, and it's B to A, so it'd be 1 to 1. All right. Again, you got to start at B, so I can count from A, but when I do my ratio, I got to make sure I pay attention. So 1, 2, 3, 4, 5, and then 1. So let's see, yep, so 1 to 5, because again, we're going from B to A, so 1 to 5. Good thing I didn't make a mistake there. Okay, now we're going to partition a directed line segment. So on a coordinate grid, you're going to have some segment, so AB. We're going to plot that to start with. So I'm going to plot A at negative 5, 2, and B at 3, 6, just as it says in the problem. I want to cut that in a ratio of 1 to 3. Again, we can't count diagonally, but we can count horizontally and vertically. So we're going to do that same concept of creating that change in Y and change in X. And now I need to cut each of these into 4 pieces, because remember, it's 4 total. So if I go to 4 pieces, for the bottom, because that's 8 total, I would be going every 2 pieces. So if I count 1, 2, 3, 4, 5, 6, 7, 8, that means every 2 would be 4 equal pieces. And then going vertically, I have 4 spaces, so that would be 1, 2, 3, 4. Okay. So now again, order matters. So from A, I'm going to go 1. Look at that. And from B, I'm going to go 3. So from B, I'm going to count 1, 2, 3. So right there. So this point where they hit, that is the partition point. So our answer for this would be the coordinate negative 3, 3. Okay, let's do another example. So again, we're going to plot the points. I want a ratio of 2 to 3. So I'm going to count horizontally and vertically because it's easier for me. And I need a total of 5 equal pieces. So when I count horizontally, 1, 2, 3, 4, 5, 6, 7, 8, I get 8/5. I know that that's ugly, but it's okay. Don't worry about fractions, people. Okay. So if I have this, I have 8/5 and 4/5. That's no big deal. Okay. From A, I'm going to go 2. So 1 plus 2 times 8/5, because that's how much I'm going, is going to be 21/5. And then from B, 1, I'm going minus this time. Okay, negative 1 minus, because I'm going down. I started at negative 1 vertically. I'm going down, so minus 3, because I want to go 3 pieces, 4/5. Okay, so you would get the point 4.2, negative 3.4. Now, I know that you might still be feeling this way, but you don't need to be. I just wanted to show you what happens if it's not a perfect number. Usually, I have never seen it on the regions where it's not like this. This is all I will expect you to do. I just wanted you to see an example where you had to use a fraction. So if you were able to follow this example, you're right where you need to be. I will see you in class. Have a great day.